Here we go, binomial probabilities. So to wrap up this unit, I wanted to talk about a special discrete random variable, which is called the binomial random variable, and hence I want to talk about probabilities related to those binomial random variables. So first of all, before we talk about probabilities, let's talk about what a binomial experiment, or sometimes is referred to as a Bernoulli trial, must satisfy the following conditions. Whenever we do this experiment, first of all, we must do it a fixed number of times. There has to be a fixed number of trials. And with those fixed number of trials, there can only be two outcomes. We're going to call those either success or failure. And the trials must be independent, meaning what we did with the first trial can't affect the second trial and so forth. And lastly, our random variable x, the values of x will be the number of successes for that particular experiment. If all four of those are satisfied, then we have a binomial experiment. For my exam, y'all, don't stress about trying to determine if it's binomial or not. I'll let you know that. But now let's talk about how do we actually calculate some probabilities. All right, so to find binomial probabilities, we're going to just jump straight to the calculator, folks. We're going to use either the Binompdf or the Binompdf function in our calculator. Okay, it's very important that we understand the difference between the two. The Binompdf function in our calculator is going to calculate the probability of having exactly X number of successes in N trials. Okay, so remember, X counts your number of successes, so X successes and N trials. And the key here, and it's very important, we're going to have to use this probability notation is what I call it. We're looking at the probability that X equals a number whenever we use Binompdf. And that is a typo there. Sorry about that. This is Binompdf. I think autocorrect got me. Binompdf. Binom short for binomial. Binompdf is a little different probability. It's going to calculate the probability of having either X successes or less than that, or fewer. For that, the notation we'll use is the probability that X is less than or equal to some number. Okay? So for right now, just keep in mind there's only two times we can use the calculator formulas, right? Only two times we can use the calculator. As if we have the probability that X equals a number, or if we have the probability that X is less than or equal to some number. If we have any other situation, any other scenario, we have to do something to that probability notation to get it to fit one of those forms. And I'll show you the tricks in a second. But just some notation, N is the number of trials. P represents the probability of a single success. And this will be given to you, it has to be given to you in the problem. And X, once again, counts the number of successes. All right? So how do we get to Binompdf or Binompdf in the calculator? Well, you hit second vars, and then you go to Binompdf or Binompdf. I'll show you in a second. And then what you have to do, once again, it depends on whether you're updated or not. If your calculator is not updated, it's going to take you back to the home screen. And in that instance, you have to manually type in an N, P, and your X, all comma separated. Where P, once again, N is your number of trials, P is the probability of a single success, X is the number of successes. If your calculator is updated, instead it's going to ask you for trials, which then you'll type in your N value. It's going to ask you for your P, but you give it the P, and it asks for your X, you tell it what your X is. All right? Okay, so really quickly, let me show you guys, let me see if I can do this, how to find this function in the calculator. Okay, let's pull up our calculator. And it was second vars, so second, and your vars button is located over here next to your clear button. If you notice in blue on my calculator it says DISTR, that means distributions. All right, second vars, and what we're looking for is Binompdf, Binompdf, not normal PDF and CDF. So let's scroll down, and depending on what type of calculator you have, I think for most of us it should be after FCDF. Yeah, so Binompdf for me is the number 0, Binompdf is the letter A. Okay, once again, depending on your calculator, you may have them slightly different numbers here representing where they're at, but they should all be located in the same place, so to speak. Second vars, and then that's how you find your Binompdf and Binompdf. Okay? Alright, so let me go back to my presentation. Okay, do we have an example? Oh, okay, y'all. So I've told you before, statistics is all about reading comprehension, okay? And so what I wanted to take just a minute to do is to present you with two tables that will be extremely helpful for these binomial probability problems. We've got to be able to turn our words into inequalities. So that's what my first table is showing you here. If you see the word more than or exceeds, we know that means a strictly greater than. Less than means a strictly less than. At least. At least. If you say you have to be at least 18 to vote, that means you have to be 18 or older. If you have to be at least 21 to purchase alcohol, that means you have to be 21 or older. All right, so at least means greater than or equal to. And I forgot one. My apologies. Another one is at most. Okay? If somebody says for dinner, at most they can afford is $20 for dinner, at most means they can't spend any more than $20. They can go up to $20 or they can spend less than that. So at most means less than or equal to. All right. These obviously are the most commonly confused ones, so make sure you understand the difference between those. And then another trick we may have to utilize is the trick of a complement. Once again, we've seen this a couple times now. Remember how I said the probability of E excuse me, is 1 minus the probability of E complement? Okay, so that's what I'm saying here. So in this right here, what I'm saying is anytime you take a complement, introduce a 1 minus. Okay. So, what are we taking complements of? Well, we may have to take complements of our inequalities. Remember, the only inequalities we can use and go to the calculator with are the equals to and the less than or equals to. If it's not one of those, we may have to take a complement of that. So what's the complement of strictly greater than? Well, complement means the exact opposite. So whenever you see an inequality, I want you to think of it consisting of two parts. The first part will be the direction, okay? And then the second part will be whether or not it has an equals to sign or not. So for instance, let's say we start off with a strictly greater than. Well, what's the complement of a strictly greater than? Well, first of all, that means flip the inequality, right? So instead of pointing to the right, we're going to point to the left, so to speak. But then notice a strictly greater than does not have an equals to sign. So the opposite of not having an equals to sign is having an equals to sign. So the complete opposite, the complement of a strictly greater than, is a less than or equal to. What about the complement of a greater than or equal to? Well, the complement of that is, well, we flip it, so it becomes a less than, and then the opposite of having an equals to sign is not having it. So the complement of a greater than or equal to is a strictly less than. Okay, there's more complements of inequalities we could play around with and calculate, but just take my word for it. These are going to be the only two that we're going to really be interested in. Okay, I think we're ready for a problem. Here we go. Suppose 60% of adults with allergies report systematic relief with a specific medication. Suppose that the medication is given to 10 new patients with allergies, okay? All right, so first of all, this is a binomial experiment. You don't have to check it, but really quickly, why? Okay, first of all, we have a fixed number of trials. We know exactly how many patients we're dealing with. We're dealing with 10. Second of all, we have two outcomes with this experiment. We give them the medication, either we have success or failure. Well, what's success? Success is going to be that the patients get relief. And failure is that they don't get relief. That's the only thing that can happen. Thirdly, we have independent trials because, well, we're assuming that each patient is independent. Each patient is unrelated. Okay, so the drugs, the effects on patient 1 is not going to affect patient 2. And then lastly, we're going to let our X count a number of successes. Okay, so this is a binomial experiment. Let's get to part A. What's the probability that the medication is effective in exactly 7 patients? Let me go back. I forgot to add a keyword. Exactly. Can I fit that in here? I think I can. All right, exactly. What does exactly mean? What I mean by that is what inequality or equality should be right. Exactly means it has to be equals. Has to be equals. Equals. All right? Okay. So the first step with these problems is going to be convert your statement of words to probability notation. And how do we do that? What's the probability that the medication is effective for exactly 7 patients? What they're asking for is what's the probability that X is exactly 7? It's the probability that X equals 7. Exactly means 7. All right? Once you have that, now the question becomes, which function in the calculator can we use? All right, so just to refresh your memory, a Binompdf means equals. Binomcdf means a less than or equal to. Well, that means for this problem, we're going to use Binompdf. Okay? All right. If we use Binompdf, well, it doesn't matter if we use PDF or CDF, we always need the same 3 arguments. We need an n, our number of trials, number of total trials. The number of trials here is going to be 10, because remember, there's a total of 10 patients. P is the probability of a single success. Well, what's the probability that we have success? They told us that 60% of adults will get relief from this medication. So our probability, P, is a 0.60. Okay, please write your percentages, your probabilities as decimals. And your X is the number of successes that you're looking for your problem. Our X is 7. Okay, so don't get your N and your X confused. Your N is the total number of people that you're dealing with. Your X is the number of successes. And you're going to get X from your parentheses when you write your probability notation. All right, so what we have to do now is simply take those values and plug them into our calculator. So here we go. All right, so if you need to, write down those values. N is 10, P is 0.60, X is 7. All right, let's bring up our calculator. And so as we discussed, we're going to do a Binompdf. So Binompdf will be second vars. And we go down to Binompdf. Scroll all the way down. Oh, past it. Okay, my calculator is not updated, so it's going to bring me back to the home screen. And what I have to do here is I have to put in NPX in that order. Has to be in that order. Okay? Comma separated. So N was 10, comma, remember your comma is the black button above your 7. P was 60%, so 0.60, comma, 7, because our X, our number of successes, was 7. We close that up, hit enter, and to 2 decimal places, I'm hoping you guys all got a 0.215. And that's our answer, 0.215. So this probability equals 0.215. Okay? So that's going to be the process for all of these, folks. You're going to write your problem in probability notation. You're going to determine if you have a Binompdf or CDF situation, and then you're going to input those values in P and X into your calculator. All right, let me do all of these so you guys are super comfortable. Part B, what is the probability that the medication is effective for more than 4 people? That's a probability that X is more than. More than means strictly greater than. Strictly greater than 4. Okay. Maybe I should come out here to remind you guys. All right, one more time. Binompdf. That's the probability that x is equal to some number. Not to be confused with Binomcdf, which is the probability that x is less than or equal to some number. All right. Well, look at our situation. We neither have an equals to or a less than or equal to. Well, now what we have to do is we have to do some tricks to get this thing to look like either an equals to or a less than or equal to. Well, first and foremost, we notice that there's no way we can make greater than 4 people become an equals to problem. So that's not going to ever happen. But what we can do maybe is, let's see here, maybe we can make this into a less than or equal to problem. Well, how do we do that? Go back to our complement table. Okay? Your goal is to make this thing look like a less than or equal to. All right? And you're going to take a complement anytime it's quote unquote pointing in the wrong direction. Greater than is pointing in the wrong direction. I have to flip it. Flip it means take the complement. Okay? So what's the complement? Well, the first thing that we write, remember what I told you before, the first thing that you write is 1 minus. Okay, anytime you take a complement, the first thing you're going to write is 1 minus the probability of x. And what's the complement of a greater than? A complement of a strictly greater than is a less than or equal to. Less than or equal to, and do not change that value of 4. Now what do we have? Now we have a situation where, hey, we have a less than or equal to. You stop, you ask yourself, does it satisfy what we need for either PDF or CDF? Yes, it does. Which one? This is going to be a Binomcdf problem. Okay. Where n is equal to, n is still 10. Same scenario, still 10 trials. P is still 0.60. In fact, for all of these problems, the n and the p won't change if we're working with the same information. But now, what's our x? Our x is the number of successes. Just simply go to your parentheses. We've got a 4 in that parentheses there. All right, our x is going to be 4. Okay. So now let's go to Binomcdf and let's input those values. All right, so to recap, the probability of x is greater than 4. We took the complement to give us 1 minus the probability that x is less than or equal to 4. We know it's a Binomcdf, and now we have n equals 10, p is 0.60, x is 4. It's just a matter of us plugging those values into the calculator. Okay, here we go. So let me get out of this. All right, here we go. So what we're going to do is we're going to go to the calculator. The first thing we're going to do is we're going to type in that 1 subtract, okay, because it's easily forgotten. So type in your 1 subtract first. 1 subtract, second vars. And we go to Binomcdf. There you go. All right, NPX. N is 10, comma, your P of 0.60, comma, your X of, what was it, 4. Okay, close parentheses. There we go. We get a 0.834. 0.834. Okay, so this equals, let me make it big. This equals a 0.834. Okay, so the key was the 1 minus, and we took the complement there, okay? All right, so what's next? So it's probably that less than 6 patients get some relief. That's a probability that x is strictly less than 6. Okay. All right. So here's the deal with this one. remember, just remind you, and I'm sorry about my pen, I don't know what it's doing, but Binompdf, remember that's the probability that x equals a number, and Binomcdf, that was for the probability that x is less than or equal to some number. Okay? So here's the deal whenever you have a strictly less than. Whenever you have a strictly less than, we got to make it look like a less than or equal to. Well, we're pointing in the right direction, so to speak. But it's a less than, not a less than or equal to. Now what we do is we take advantage of the fact that this is a discrete random variable. Well, what does that mean? That means that there can only be whole numbers here. So remember what strictly less than 6 means. It means you don't quite get to 6. So you're talking about a number like 5.999, right? Well, think about it. You can't have 5.99 people. All right, you can't have 5.5. You can't have 5.2, 5.1. So being less than 6 whole people is the exact same thing as being less than or equal to 5 whole people. And this will always be the case because a binomial random variable is a discrete random variable, meaning there's whole numbers, there's gaps in the numbers there. Okay? So the probability of us being less than or equal to 6 is the exact same thing as being less than or equal to 5. Now that we see that, now we know that we're dealing with a Binomial CDF situation where n is still 10, p is still 0.60,
and x is equal to 5.
Okay? Does that make sense there? So whenever you do the less than down to the less than or equal to, what you're doing is you're changing the x value, but you're not doing a 1 minus. Anytime you're doing 1 minus is whenever you have to flip the inequality, take a complement. Okay? All right, so what's that answer? Let's see here.
All right, so we're going to go to second vars. We're going to go all the way down to Binomcdf. All right, let's see here. Our trials is the number 10. Our p is 0.60. And our x value is 5. All right, we're going to paste this to our home screen. And so remember, your folks with the calculator is not updated. Remember, you're going to put these in comma separated, but we can see here 10, comma 0.60, comma 5. We're going to execute that, and we get a 0.367. 0.367.
This equals
0.367.
Okay? All right. Last one. What is the probability that the medication is effective for at least 5 of the patients? This is the probability that x at least means greater than or equal to 5. Okay, so here's the deal, folks. We got that thing pointing in the wrong direction. So our first step here is to take a complement. When taking a complement, the first one we write is 1 minus. The complement of a greater than or equal to is a strictly less than 5. Okay? Now we realize we're still not there. Well, what could we do? Well, being less than 5 whole people is the same as being less than or equal to 4. Okay? So this will be 1 minus the probability that x is less than or equal to 4. So in this case, we had to do both of our tricks. What are our tricks? Our tricks are if you're trying to get down from a less than to a less than or equal to, you subtract away 1 from the x value. And our other trick was if it's a greater than or a greater than or equal to, you take the complement to get it down to what you need. All right. So now we're at a Binompdf situation. Okay. And now we have an n is equal to 10. P is still 0.60, and our x is equal to 4. going to subtract away, and then second vars. Binom CDF is what we're scrolling down to. N is 10. Comma, P is 0.60. Comma, X is 4. Not 40, but 4. Alright, close parentheses, hit enter. And yes, the 0.834 as we saw from before. Alright, so you guys have now seen the bulk of the situations when it comes to these binomial probabilities. Alright, quickly wrapping this up. This is a long video. Alright, lastly I'm going to ask you to find the mean, variance, and the standard deviation of a binomial random variable. Okay? The mean is n times p. What's n? N is the number of trials. Same number of trials that you had to use for before. What's P? P is the probability of success. Okay, so to get your mean or your expected value, as we talked about in previous videos, it's just n times p. Your variance. So your variance of this binomial random variable is a really straightforward formula. It's n times p times q. Well, what the heck is q? We know n and p. What the heck is q? Well, q will be, let's see, only two things can happen with the binomial random variable. Either success or failure. So what's q? Q is the probability of a failure. Okay? And then, of course, the standard deviation will always be the square root of your variance. All right? Here we go. Same scenario. 60% of people with allergies will get relief from this, this medication. We're going to give it to 10 people. What's the mean, variance, standard deviation, and the expected value for this situation? The mean is n times p. What's n? How many patients do we have? We have 10 patients. And we multiply it by p, which is 0.60, which gives us 6. So the mean is equal to 6, which is also the same thing as the expected value. Okay, the mean is the same thing as the expected value. Alright, the variance. The variance is n times p times q. Well, n is 10, p is 0.60. What the heck is q? Well, q is, let me come back up here. Q is, if only two things can happen, either success or failure. Q is just simply 100% minus your probability of success. 1 minus p. So if there's a 60% chance that you succeed, there's a 40% chance that you fail. 100% minus 60% gives us 40%. So Q is 40%. Okay? Which should give us, let's see, 10 times 0.60 is 6. 6 times 40% of that should be, I don't know, 2.4. Then lastly, our standard deviation. Is the square root of what we just calculated. So the standard deviation is the square root of 2.4, and that I do not know. My trusty calculator tells me that the square root of 2.4 gives us roughly 1.5. And that is our standard deviation. Okay. So here, same scenario, I want you guys to figure out what's the probability that the medication is effective for more than 7 people. Remember, write out your probability notation, get it to the correct form, and then go to your calculator. All right, folks, take care.